be learning how to graph systems of inequalities. A system of linear inequalities is a set of two or more linear inequalities, and they are graphed on the same coordinate plane. So for example, we have y is less than 2x minus 1 and y is greater than or equal to negative 2/3 x plus 4. So those two inequalities would be graphed on the same coordinate plane. The solution of a system of linear inequalities are all of the values of the variables x and y that make all of the inequalities in the system true. So you're going to find where the shading overlaps. And all of the points in that shaded area that overlaps will be the solutions to the system. So let's look at an example. What is the solution of the system of linear inequalities below? So first we have y is greater than or equal to x minus 3. So we're going to be looking at the green line. And we have the line plotted, but we're going to shade, and we have y is greater than or equal to x minus 3. So we're shading above that line. The other line that's plotted there is y is less than or equal to negative 2x. So that's the blue line, and we just need to shade below the line because y is less than or equal to. So this area where the shading overlaps, right there, is the solution. So we shaded above the line here, and we shaded below the line here. So find one point that lies within the solution set, the overlapping shaded area. So we can pick really any point. I'll go ahead and pick this one here. I'm going to do it in black. So I'll pick this point. That is negative 2, negative 1. That's one of the solutions. There are many points you can choose within that solution set, that double shaded area. So we could have picked negative 1, 0, which is here. We could pick negative 1, negative 2, which is this one. We could pick negative 3, 2, which is here. So any of those points is a solution within the solution set. When we ask you to list a point, I'm just making sure that you know where the double shaded area is, the overlapping shaded area. So here are the steps to solving. Make sure the inequalities are in slope-intercept form. Remember, that's y, well, I guess it would have an inequality mx plus b. So remember, that inequality symbol can change depending on the inequality that you're given, but it's y equals mx plus b with an inequality symbol. So you're going to complete steps 2 through 4 fully for the first inequality, and then you're going to repeat for the other. So first you're going to identify slope and the y-intercept to graph each line. Decide whether the line should be dotted or solid. And decide if you're going to shade up or shade down, above or below the line. Okay, so you would graph the first inequality and then repeat those steps for the second inequality. The solution set is the double shaded region. Then your last step is to identify one point, xy, that lies within the solution set. There are many. Possible answers. So let's practice some of these systems. Number 1, y is greater than or equal to x minus 8. So let's identify m and b. M is 1, so rise over run is 1 over 1, and b is negative 8. So let's graph this. Oh, let's first say, okay, this will be a solid line, and we are shading up because it's greater than. Okay, so negative 8 is where I start on the y-axis. The rise over run is 1 over 1. So all of my points will go up 1 and 1 to the right, and we'll go back in the opposite direction, down 1 and 1 to the left. Once I have all my points plotted, I'll go ahead and draw the line. I do want you to plot your points all the way across the graph, because in a system, you want to make sure your line is very straight so you can actually see where the solution is. And we are going to be shading above this solid line. Okay, the second inequality is 2x plus y is greater than 1. Now this is not in slope-intercept form. This is in standard form because x and y are on the same side. We need it to be in slope-intercept form, so let's convert it. We will subtract 2x, y is greater than negative 2x plus 1, and that's our slope-intercept form. So m is negative 2 over 1, and b is 1. This will be a dotted line, and we will shade up because it's greater than. So on the same graph, plot b on the y-axis, and we'll be going down to 1 to the right, all the way across the graph. So this is a dotted line, so I'm just going to leave it like that with my dots since they're so close together. And I will be shading above this line, which is here. Now, where is my solution? It's where those shaded regions overlap. So this is my solution set. I'm going to name one point in the solution set. I'll go ahead and pick this one here. That coordinate is 3, 2. There are many possible options. You could have picked any point in this double shaded region as long as you can identify where it is. Number 2, y is greater than 3x minus 4. So m is 3 over 1. And b is negative 4. This will be a dotted line, and we'll be shading up. So negative 4 on the y-axis, up 3, 1 to the right, all the way across the graph, and back in the other direction. This is a dotted line, so I'll just add some dashes in. And we are shading above the line. The second inequality is x plus 2y is less than 6. This one's in standard form, so we need to convert it. Subtract x. 2y is less than negative 6 plus x. Divide by 2. Y is less than negative 1/2 x plus 3. So M is negative 1 over 2, and B is 3. This will be a dotted line as well, and we will be shading down because it's less than. So plot B on the y-axis, down 1, 2 to the right. And this one's a dotted line, and we'll shade below that line. Okay, name a point in the solution set, so we'll find the area that is overlapping. I'll go ahead and pick this point here, negative 5, 0. Number 3, y is less than 1/2 x plus 2. Slope is 1/2. Y-intercept is 2. This will be a dotted line, and we're shading down because it's less than. So the y-intercept is 2, up 1, 2 to the right, all the way across the graph, and back in the opposite direction. And we will shade down. And now we have negative x minus 2y is greater than or equal to 8. So we need to convert this to slope-intercept form. Add x. Divide by negative 2. When we divide by a negative number, remember you have to flip the sign the other direction. So y is less than or equal to negative 1/2 x minus 4. So slope is negative 1 over 2. The y-intercept is negative 4. This will be a solid line, and we're going to shade down. So negative 4, and we'll go down 1 over 2. And this is a solid line. And we will shade below the line. And let's pick a point in the solution set. So I'm going to pick negative 5, negative 5. Any point in the overlapping region. Last example, y is less than or equal to negative x plus 3. So my slope is negative 1 over 1. Y-intercept is 3. This will be a solid line, and we're shading below the line. So 3 is the y-intercept. Down 1, to the right 1, all the way across. And this is less than or equal to, so it is a solid line. And we'll shade down. And for negative x plus y is less than or equal to 5, converted to slope-intercept form. Y is less than or equal to x plus 5. So slope is 1 over 1, 1 over 1, and y-intercept is 5. Solid line, shade down. So y-intercept is 5. It's a positive slope. And a solid line. Oops. shade down. Oops, I'm shading the wrong area. There we go. Okay, so a point in the overlapping area would be 0, -5. You could pick any point in that overlapping area. So that's what you'll be doing in today's practice.